This question asks you to identify which statements correctly describe how the alpha's parameter, which controls the regularization strength in a multitask elastic net regression, works in the Sklearn library. It's a test of your knowledge about this specific machine learning tool. Let's dive in. I disagree with this statement. The alpha's parameter in MultiTaskElasticNetCV isn't a single number. Instead, you provided a range of values, so the algorithm can find the best one through cross-validation. Think of it like searching for the best ingredient amount in a recipe. This is precisely correct. You should supply alpha's as a list or NumPy array of floating point numbers. Each number represents a different regularization strength that the model will test. The model will then choose the value which produces the best model performance according to a specified scoring metric. It's a smart way to find the optimal setting. This is another true statement. Once the model completes its cross-validation process and selects the best alpha, it conveniently stores that optimal value in the alpha attribute. You can readily access it after model training is complete. It makes accessing the best hyperparameter very easy. I'll explain why this is false. The alpha parameter influences both L1 and L2 regularization in ElasticNet. The L1 ratio parameter controls the balance between them, but alpha scales the overall strength of both penalty terms. It's a combined effect, not just L1. This describes the overall context of the problem. We're working with MultiTaskElasticNetCV a tool designed for tuning hyperparameters and multitask regression using ElasticNet regularization. This involves finding the best settings, hyperparameters, for the model. The core of the quiz is understanding how to use this tool. We're exploring the alpha's hyperparameter within the Sklearn linear_model MultiTaskElasticNetCV function. Think of alpha's as a knob that controls how strongly the model is penalized for complexity. A more complex model, one that tries to fit the data too closely, might overfit. The alpha's parameter helps to prevent that. This is part of a regularization technique, specifically the ElasticNet method which combines L1 and L2 regularization. This statement is incorrect. I wouldn't use a single value. Instead, I test several values to find the best one. We need to explore different strengths of regularization, and that's what a range of values does. Think of it like trying different levels of spice in your recipe. This is correct. That's exactly right. I supply alpha's as a list or array containing multiple values. This allows the model to try many different regularization strengths and pick the best one through cross-validation. This helps find the optimal balance between model complexity and accuracy. Absolutely correct. After the model searches through the different alphas you provided, the optimal alpha found is automatically saved into the alpha attribute. I can access this value to see which regularization strength the model found to be the most effective. This is wrong. Alpha controls the overall strength of both L1 and L2 regularization in ElasticNet. The L1 ratio parameter controls the mix between the two. It's not just influencing one, it influences both penalties proportionally. This line simply indicates the type of question. A multiple-choice quiz about the alpha's parameter in MultiTaskElasticNetCV. This is the title. It tells us the focus is on understanding the alpha parameter within the MultiTaskElasticNetCV function from the Sklearn library. This function helps us build models for multiple regression problems simultaneously. This section poses a multiple-choice question about how the alpha's parameter works in MultiTaskElasticNetCV. I'll need to carefully assess each choice using what I know about the function and its parameters. This statement is correct. The alpha's parameter doesn't take a single value. Instead, I need to provide a collection of numbers, either a Python list or a NumPy array, representing different regularization strengths. The model will then try each of these values and choose the best one. Think of it like trying different settings to find the optimal one. This is like testing different amounts of seasoning to find the perfect taste for a dish. This is also correct. After the model finds the best alpha value from all the options I gave it, it helpfully stores this winning value in the alpha attribute. I can easily access this to see which regularization strength produced the best results. It's like keeping a record of the winning recipe. This statement is false. As explained above, I need to provide several values, not just one. This statement is also incorrect. The alpha parameter influences both L1 and L2 penalties. It works alongside L1 ratio to control the overall effect of regularization. This refers to the hyperparameter alphas within the Sklearn's MultiTaskElasticNetCV function. It controls the strength of regularization in a multitask regression problem. I'll explain the alphas parameter further. Think of it like this. We're trying to find the best balance between fitting the data well and avoiding overfitting. Alphas helps us do that. This is the core question of the quiz. We need to determine which statements accurately describe the alphas parameter and its behavior in the MultiTaskElasticNetCV model. This statement is incorrect. The alphas parameter doesn't work with just a single value. Instead, it requires a range of values. This statement is correct. MultiTaskElasticNetCV needs a sequence of alpha values to test during cross-validation. For instance, you might use alphas equals 0.1, 0.5, 1.0, 2.0, dot. This is also correct. After the cross-validation process completes, the model automatically picks the best alpha value, and you can access it using the alpha attribute. This is super convenient. This is incorrect. The overall regularization strength is influenced by alphas the L1 ratio parameter, another hyperparameter, determines the relative weight between L1 and L2 penalties. I'm focusing on the alphas hyperparameter within the Sklearn linear_model MultiTaskElasticNetCV function. This hyperparameter controls the strength of regularization in an elastic net regression model. Think of it as a dial that adjusts how much we penalize large coefficients in our regression model. A larger alpha value means stronger regularization, making the model simpler and potentially less prone to overfitting. It's a crucial parameter for tuning our model. The question tests your understanding of how the alphas hyperparameter works in the context of MultiTaskElasticNetCV. It is a multiple-choice question asking which statements are true about the alphas parameter. We need to understand what alphas represents and how it's used by the MultiTaskElasticNetCV function. This is the core of the multiple-choice question. The question asks you to evaluate 4 different statements about the alphas parameter and decide which are true. Each statement needs to be evaluated based on your understanding of MultiTaskElasticNetCV. This refers to the alpha hyperparameter within the MultiTaskElasticNetCV algorithm. I'll explain what that means. The MultiTaskElasticNetCV algorithm uses a combination of L1 and L2 regularization techniques to prevent overfitting. The alpha parameter is important because it directly controls the strength of this combined regularization. You should not provide a single value for alpha, but rather a range of values, a list or NumPy array of floats. The algorithm then tries each value in your range to see which one works best. This is called hyperparameter tuning, and it's like trying different amounts of seasoning to find the perfect taste for your dish. After the algorithm tries out all the different alpha values, it remembers which one worked the best. That best alpha value is conveniently stored in the alpha attribute. I find that to be useful. This is a special attribute of the MultiTaskElasticNetCV object. After you run the algorithm using a range of alpha values, as explained in point B, the best alpha it found is saved here in alpha_. It is a great way to find the optimal regularization strength. This section's title tells us we'll be focusing on the alphas parameter within the scikit-learn function called "MultiTaskElasticNetCV". This function is used for a type of machine learning called multitask regression, where we try to predict multiple outputs at once. The alphas parameter is key to controlling how much the model is regularized. The question tests your knowledge of how the alphas parameter works in the "MultiTaskElasticNetCV" function. I'll be breaking down each option to help you understand. Let's dive in. This statement is correct. You don't give "MultiTaskElasticNetCV" a single value for alpha. Instead, you provide a range of alpha values. The algorithm then tests each value and selects the one that produces the best model performance. Think of it like trying different levels of seasoning for a dish. You want to find the perfect amount. This is also correct. After you run "MultiTaskElasticNetCV" with your data and range of alpha values, the best performing alpha value will be saved in the "alpha_" attribute of the fitted model. It makes it easy to find the optimal amount of regularization without checking all the alphas yourself. This statement is incorrect. The alphas parameter in "MultiTaskElasticNetCV" controls the overall strength of regularization, which is a combination of L1 and L2 penalties. The "L1_" ratio parameter determines the balance between L1 and L2, while alphas influences the magnitude of both penalties simultaneously. This refers to the specific scikit-learn function used in the problem. "MultiTaskElasticNetCV" implements elastic net regularization for multitask regression problems. Multitask means it handles multiple prediction targets simultaneously. Elastic net refers to a type of regularization that combines L1 and L2 penalties to prevent overfitting. The CV indicates that the function automatically performs cross-validation, which is a technique to get a more robust estimate of the model's performance.